Good morning, children. Today I shall teach you about the how to calculate the number of electrons constituting coulomb of charge. So here first of all we understand about the definition of 1 coulomb of charge. We know that when two similar charges they are separated to each other through 1 meter distance, and then this charge exerts 9 into 10 to power 9 Newton force or repulsive force to each other, then this charge is known as 1 coulomb of charge. 1 coulomb of charge. So here the similar charge repel to each other through 9 into 10 to power 9 Newton force when they are separated to each other through a distance 1 meter in a space, then it is known as 1 coulomb of charge. Now we know that the charge has also the many properties. Out of many properties, one property here we explain about the quantization of charge. Here the quantization of charge means here the multiple integral of charge. Multiple integral of charge is known as quantization of charge. So here quantization of charge represented by the Q. So here Q is equal to NE. Q means represent the quantization of charge, means relative charge. N represent the number of electrons, and E represent the absolute charge or basic charge or fundamental charges, which value is 1.6 into 10 to power minus 19 coulomb. Now how to calculate how many electrons constituting in 12 coulomb of charge means now we can find the number of electrons through the constituting of charge. For example is given here how many electrons constituting in 12 coulomb of charges. So first of all the relative charge means Q is given 12 coulomb of charge. Q is given 12 coulomb of charge. E is given 1.6 into 10 to power 19 coulomb, and we can find here number of electrons is equal to what? So we know that here Q is equal to NE. So therefore or N is equal to Q by E. Q by E. Then putting the value of Q and E, Q here given 12 coulomb of charge and E given here 1.6 into 10 to power minus 19 coulomb. Coulomb cancel. Then here we get here decimal is given cancelled here, then 10 put in numerator, and also here 12 into 10 to power 19 by 16. So 4 3s are 12 and 4 4s are 16 is equal to 3 by 4 into 10 to power 19. So therefore Q is equal to 0.75 into 10 to power 19 is equal to 7.5 into 10 to power 19. 10 to power 19 electrons. So here 10 to power here n is equal to 0.75 into 10 power 19 electrons. So we can find the number of electrons in 12 coulomb of charge is equal to so here n is equal to 7.5 into 10 to power 19 electron. So we can find the value of number of electrons through the properties of the quantitation of charge. Second question, example second. Example second. How many electrons in 1 milliampere of current, in 1 milliampere current. So here also, first of all, we can find here the 1 milliampere, 1 milliampere to 10 to power minus 3 ampere current. Now here I is equal to Q by T. I is equal to Q by T. Then Q is equal to IT is equal to 10 to power minus 3 ampere into time is equal to 10 to power minus 3 ampere means here coulomb by time into time, time cancel, we get here 10 to power minus 3 coulomb. So you here get the Q is equal to 10 to power minus 3 coulomb, and we also know about the value of the absolute charge. Value of the absolute charge. Value of the absolute charge is equal to 1.6 into 10 to power minus 19 coulomb. So therefore N is equal to here Q by E is equal to 10 to power minus 3 coulomb by 1.6 into 10 to power minus 19 coulomb. Coulomb cancel. Then here we get the 10 to power minus 3 into 10 to power 19 by 1.6 electrons. Then we get here 10 to power 16 by 1.6 is equal to 10 by 16 into 10 to power 16. Now 5, 8. Then we get here the 5 by 8 into 10 to power 16 electrons. 16 electrons is equal to 0.625 into 10 to power 16 is equal to 6.25 into 10 to power 15 electrons. 15 electrons. So therefore N is equal to 6.25 into 10 to power 15 electrons. So we get the value of electrons through the properties of the quantitation of charges, and we get the value through the flowing the current. We can find the number of electrons, and also through the flowing the charges through in a circuit we can find the number of electrons. Thank you.